Let us explore kinematics in one dimension. As we recall, we defined kinematics as the study of motion. In one dimension, it means along one direction. It can be a horizontal direction, vertical direction, up and down, or any direction. It's a motion along a line. Okay, as we mentioned earlier, these are possible quantities that we usually use in describing motion: position, displacement, distance, speed, velocity, acceleration, time. Okay, and we start defining each one of these. We discussed position earlier. So position is a point, a location, and it is a vector. We define it relative to a frame of reference, to a reference point. It's going to be given in terms of a distance away from that reference point and a direction relative to our frame of reference. Now, displacement is defined as change in position. It is change in position, which is a final position minus an initial position. Look at the symbols here I'm using P for position, sub F to say final, and here sub I to say initial. And they are vectors, both of them. Whenever we add vectors or subtract vectors, we get another vector, which is in this case our displacement vector. We are using the symbol D for it. The magnitude of the displacement is going to be a distance. It's going to be measured in meters. A distance or a length. It's going to be measured in meters. And since it is a vector, the direction is going to be important. Distance, on the other hand, is not a vector. It is in meters. The direction is not important. Distance does not have a direction at all associated with it. It is always positive. As we progress through this model, you'll figure out that actually we will not use distance quite a bit. We might refer to it in our description, but distance is going to be mainly used to give us the magnitude of a displacement. But by itself, a distance, since it is devoid of direction, it's not going to be as useful for us to predict things and to make calculations. Let's look at this example. We have a racehorse that runs 1500 meters full circle in a racetrack. What is the displacement of the horse? And then what is the distance traveled by the horse? So in this case, we are starting here. We are going full circle to come back here. They're asking us about the displacement. Initial position is here. Final position is here. So the displacement, which is final position minus initial position, is going to be 0, since the final position is the same as the initial position. So by making a full turn, the overall displacement of the horse is 0. Okay, that's important. What about the distance traveled by the horse? In the case of distance, we don't have to worry about direction. It is not a final position minus initial position. How far did he travel? Distance traveled is 1500 meters. Notice here something that's very important. We said that for a displacement, the magnitude is a distance. But that does not necessarily that the magnitude of this vector is this distance. They are independent of each other. For this displacement, the magnitude is 0. The distance in this case is 1500 meters. They are not really related.